Greetings everybody, and welcome to our second video in our series on normal distributions. So what we're asked to do in this problem is that a teacher is given a test to a large group of students. The results are closely approximated by a normal distribution with a mean of 72 and a standard deviation of 5. The teacher wishes to give A's to the top 8% of the students, F's to the bottom 8%, a grade of B to the next 15%, and D similarly with all other students getting C's. So find the bottom cutoff to the nearest whole number for a B. So the idea is that we have a normal distribution of scores. And so that normal distribution is going to look something like this, where we're told that our mean, our highest point, is going to be at 72, and we're told that the standard deviation is going to be 5. Now, what the teacher wishes to do is to divide up this entire range so that the top 8% of students, so the top 8%, so here we have the bottom of A range, the area for that top 8%, and that top A range is going to be 8%. So we have 8% in that area. Then we have B range over here, and the B range is going to be the next 15%. And so what we have for the B range, if we draw this area, we're told that this area is going to be 15%. Then we go to the bottom range. So down here on the F side, we're told that the area over in the F range is also going to be 8%. Then for the D range, we have that similar to the B range in that that range is also going to be 15%. So 15% for the D range. And then finally, the C range is going to be everything else in between, so the rest of our area. And so what we're asked to do in this case is to find that bottom value for the B range. Well, we can do this by taking this normal distribution and then looking at it in terms of our standard normal distribution. And we'll do that by matching areas. So here we have an area of 8% for A range and 15% for B range. So those two ranges together constitute 23%. Okay, so we want to find the z-score down here that's going to give us an area above that z-score of 23%. Well, if we wish to look up our table, then our table is going to give us the area between the y-axis and our z-value. So the table is actually going to give us this area here. And since our area above the z-value is going to be 23, that means that our area below the z-value has to then add up to 0.5 or 50%. And so that means that our area in between the y-axis and the z-value is going to be 0.27 or 27%. And so with that, we can go over to our standard table of areas for the standard normal distribution. And we want to look up an area of 0.27. And so if we kind of zoom in a little bit from that, we see that our area of 0.27 is going to be right here at a z-value of 0.74. So we have our area of 0.27, our z-value of 0.74. So this gives us a z-value of 0.74. Now we can actually use our z-score function to go back to our x value. So remember that our z-score function is going to look something like z is equal to x minus mu over sigma. So in this case, again, we've got a z-score of 0.74. The x value we want to know. We're told that the mean is 72 and our standard deviation is 5. So now solving this equation for x, we can multiply both sides by 5 so that our 5's cancel. And that's going to give us 3.7 over on the left-hand side and x minus 72 over on the right. Well, adding 72 onto both sides is then going to give us an x value of 75.7. And so what is the minimum cutoff for our B range? It will be 75.7. So hopefully you've enjoyed this, and I will see you guys in the next video. Take care.